Namaskar. In last few sessions we discussed about set of parameters. We started with Z parameters, then we spoke about Y parameters, and then we discussed H parameters as well as G parameters. So, in today's session we will discuss about transmission parameters. So, let us see what is the transmission parameters. Basically, there are no restrictions on which the terminal voltage and current should be considered independent and which should be dependent. So, we have 4 variables V 1 I 1 and V 2 I 2. So, we can choose any one set of voltage or current as a independent parameter and any set we can consider as a dependent parameter. So, based on the choice we can generate many sets of such parameters. So, we discussed few of the parameters in our previous lectures. So, today we will discuss about another set of parameter which relates variables at the input port to those at the output port. That means, the V 1 I 1, that is the variable we get at the input port, will be related with the output port variable, that is V 2 and I 2, and these set of parameters are known as ABCD parameters, or you can also say them as transmission parameters. Now, ABCD parameter is very important in power systems because it provides a measure of how circuit transmits voltage and current from source to load. So, here the relationship between V 1 I 1 and V 2 I 2 is important. So, we will discuss the ABCD parameters today. So, how we will relate these ABCD parameters with respect to the circuit variables. The relationship between terminal voltage and terminal current can be stabilized with the help of these two equations. So, here the input port voltage, that is V 1, can be written in terms of output port voltage and current, and it is defined as V 1 is equal to A V 2 minus B I 2. Similarly, input port current I 1 can be related to V 2 I 2, and we can write I 1 equal to C V 2 minus D I 2. Now, in matrix form we can write V 1 I 1 would be the vector at that is the dependent variable vector, and that can be represented as matrix ABCD multiplied by the independent vector having V 2 and minus I 2 as the variables. So, now in this case, if you see, ABCD can be written as capital T, and this defines the transmission parameters. So, either you can write ABCD or you can simply write T, both will represent the same set of ABCD parameters. Now, this is very important in the analysis of transmission lines because now they are expressing the sending end voltage and currents in terms of receiving end voltage and current. So, because of this particular property we call them as a transmission parameters. Now, the above equations which we discussed relate the input variables V 1 I 1 to output variable V 2 and minus I 2. So, here the important thing is that till now we shown the relationship between V 1 I 1 and V 2 I 2. Here we are considering the opposite sign of I 2, because when you see the transmission network, you take the simple power system network where the V 1 I 1 is inside the network and V 2 is the output port voltage, and current generally goes out of the circuit. So, because of this specific condition related to power system network, rather than stabilizing the relationship between V 1 I 1 and V 2 I 2, we stabilize the relationship between V1 I1 and V2 n minus of I2. So, I2 we generally consider in this direction, but since the load, if you connect, consumes current rather than providing current. So, that is why the transmission parameters can best be described by reversing the sign of current I2. So, that is why we use here minus I2 rather than I2. Now, let us see how we will calculate these parameters. The parameters we can calculate by setting V2 is equal to 0. That means, you set the output port as short circuited, or I2 equal to 0, that means you set output port open circuit. Now, the equations which we saw in terms of ABCD parameters, which relates V1 I1 with V2 I2, is like this shown in the slide. V1 is equal to A V2 minus B I2, I1 is equal to C V2 minus D I2. Now, in these equations, if you set I2 is equal to 0, that means you are setting output port as open circuit. In that scenario, the value of A will be V1 upon V2. So, you can see from this equation, if you set I2 is equal to 0, A will be V1 upon V2 and C will be I1 upon V1. So, in this equation, if you set I2 is equal to 0, it will become C will be equal to I1 upon V2. So, this would be V2. Now, next is the condition when you set V2 is equal to 0. That means, you are keeping output port short circuited. That means, you will set the value of V2 in these two equations as 0. So, B which you will get from the first equation is minus of V1 upon I2, and D you will get from the second equation, that is equal to minus of I1 upon I2. Now, what these parameters are representing? If you see A is nothing but a reverse voltage gain, B is nothing but the impedance, C is the admittance, and D is current gain. So, what we can say that since the transmission parameters provide a direct relationship between input and output variables, they are very useful in cascaded networks. That means, if you have two networks connected in cascaded fashion, so you can say that here the parameters are V1 I1, intermittent parameters you can say V1 dash I1 dash, and output you may have V2 and I2 as a variable. So, the transmission parameters will help you to stabilize the relationship in those cases when you have cascaded networks. So, analysis of these kind of networks we will see in the next lecture when we discuss about the interconnection of various networks. We will see that particular aspect in detail. For today's lecture, we will first discuss the key properties of the transmission parameters. So, we will see what are those the properties. First, let us see what ABCD defines. A will be your open circuit voltage ratio, because this you calculate when you keep output port as open circuit. B is negative short circuit transfer impedance, C is open circuit transfer admittance, and D is again negative short circuit current ratio. Now, one of the important property of in case of ABCD parameter is that if you want to see whether the particular two port network is reciprocal or not, you need to find out with the help of this condition. So, if AD minus BC equal to 1, we will say that the circuit is reciprocal. Now, how will determine the value of ABCD? We will determine the values of ABCD similar to what we did in case of Z, Y, or in case of H and G parameters. Means we will first open circuit the output port, and then we will short circuit the output port and find out the value of ABCD parameters. Now, next is the opposite of what we discussed till now, means the relationship will now be the V2 and I2 will be related with respect to V1 and I1. That means we can also set V1 I1 as independent variable and V2 I2 as dependent variable. In that case, the relationship which we get is called as a inverse transmission or inverse T parameters. So, we stabilize this relationship with the help of small ABCD because it is opposite to the capital ABCD parameter which we discussed till now, where we stabilize the relationship of V1 I1 with respect to V2 I2. In this case, the relationship will be the V2 I2 with respect to V1 I1. So, here V1 I1 is independent, V2 I2 is dependent. So, how we will write? V2 is equal to A, that is small a V1 minus small b I1, I2 is represented as small c V1 minus small d I1, or alternatively in the matrix form you can write it like V2 I2 will be the dependent variables vector, and then this will be equal to ABCD small ABCD matrix, then independent variable vector, that is V1 and minus I1. So, we represent this ABCD matrix with small t. So, we say it as a inverse transmission or small t parameters. Now, how you will find out the values? You will apply the same criteria which we did in the case of transmission parameters. Here the value of parameters can be evaluated by now setting V1 equal to 0, that means open port is short circuit, input port is short circuited, and I1 it is equal to 0, that means input port is open circuited. How you will find the values of parameters? First you will set I1 equal to 0. So, when you set I1 equal to 0 means you will get A is nothing but V2 upon I1, C is nothing but I2 upon V1. So, A is now V2 upon V1 and C is I2 upon V1. In next case what we will do? We will set V1 equal to 0. So, if you set V1 equal to 0, you will get B as minus of V2 upon I1 and D as minus of I2 upon I1. So, you get minus of V2 upon I1 as B and D equal to minus I2 upon I1. So, what you can write? A is nothing but open circuit voltage ratio. What is B? B is negative short circuit transfer impedance, because it is basically the relationship ratio between V and I. So, it is negative short circuit transfer impedance. C is open circuit transfer admittance, because it is V by I ratio, I by V ratio, and then D is negative short circuit current ratio, that is relationship between the ratio between I2 and I1. So, these small ABCD parameters can also be utilized in case of the transmission lines, particularly the power systems, because here also we get the impact of output variables, that is V2 I2 on the input variables, that is V1 I1. So, here we will say that the circuit is reciprocal again if AD minus BC equal to 1. Now, let us see couple of examples to understand the transmission parameters. let us see, there is one circuit as given in the figure. We have two resistances and one dependent voltage source, and we need to find out the transmission parameters for this particular circuit. So, we will use the equations and we will set first voltage, the output port as open circuit, and then short circuit to find out the circuit parameters. So, now in first case what we are doing, we are opening the output port and the input port, we have a voltage connected, that is V1, and when we have this particular condition, we put these values in the ABCD equations, that is V1 I1 equations. So, when you put these the values by setting V2 by setting I2 equal to 0, how you will get? So, from this figure, if you see I1 is flowing in this particular loop. So, you can simply say V1 is nothing but equal to I1 into 10 plus I1 into 20. So, V1 you will get in terms of I1 as 30 I1. Similarly, for V2, what you will write? V2 is applied across the dependent voltage source as well as across the 20 ohm resistance. So, in this particular 20 ohm resistance, the current flowing is I1. So, the voltage drop across 20 ohm will be 20 I1, and since the dependent voltage source is connected in opposite polarity with respect to V2. So, we will write this particular voltage drop as minus of 3 I1. So, I1 is common, we take it out. So, it will become 20 minus 3. So, V2 will now become 17 I1. So, V1 and V2 we have got with respect to input current I1. So, what you can write now with the help of the equations for ABCD parameters, we know that A is nothing but equal to V1 upon V2. So, V1 we got as 30 I1. So, we have put value of V1 as 30 I1 and V2 as 17 I1. So, the ratio for A, the value of A which we get from this is 1.765. Similarly, for C, we know the relationship, the C is nothing but the ratio of I1 and V2. So, C is equal to I1 upon V2. I1 we keep like this and write the value of V2 in terms of I1. So, this we just now calculated, V2 equal to 17 I1. So, we put the value and we get the value of C as 0.0588 Siemens, because this is admittance. So, you can set the unit also as Siemens in this particular case. Now, next we have found the value of A and C. Next we need to find out the value of B and D. So, for that what we have to do? We have to short circuit the output port and apply a voltage V1 in the input port and solve the equations. So, how you will solve? You will, if you see the circuit, you can apply Kirchhoff current law at this node. Let us say the voltage at this node is VA and we apply Kirchhoff current law at this node. So, what we can write? We can write the value of I1 is nothing but V1 minus VA by 10, and the current is going inside. So, we are taking current going inside as positive, current going outside as negative. So, the current going in the 20 ohm resistance will be minus of VA by 20 plus the current I2 equal to 0. Now, if you see this particular the circuit, you can say that VA is nothing but equal to the voltage of dependent voltage source, because this is the voltage which is applied across the 20 ohm resistance, and the voltage which is applied across 20 ohm resistance is nothing but V A. So, what you can write? You can write V A equal to 3 of I 1, and from this section we have already seen that I 1 is nothing but V 1 minus V A upon I by 10. So, we have these two informations in our hand. So, what we can now say, the value of V 1 in terms of I 1, because V A we know as equal to 3 of I 1. So, we can put it here, and when you simplify you get the value of V 1 as equal to 13 of I 1. So, if you just put value V A equal to 3 I 1 here and simplify, you will get V 1 is equal to 13 I 1. Now, what you have to do? You have to put the values of V 1 and V A in this equation. So, what you can write? V 1 minus V A by 10 is anyway we know that equal to I 1. So, we have just put I 1. V A is now 3 I 1. So, 3 I 1 by 20 will be the current flowing through 20 ohm resistance, and plus I 2 equal to 0. So, what you get? You get the output as I 1 equal to minus of 20 by 17 I 2. So, what you can now write, since I 1 is equal to minus of 20 by 17 I 2, the ratio between I 1 and I 2 is the value of D. So, D is nothing but minus of I 1 by I 2. So, from this what you get? D is nothing but equal to 20 by 17. So, value of D you will get as 1.176. Similarly, you can find the value of B. B is nothing but minus of V 1 upon I 2. V 1 we know in terms of I 1, we just calculated. So, that is 13 of I 1, then divided by I 2. I 2 we just found in terms of I 1, that is minus of 17 by 20 I 1. So, when you simplify you will get B as 15.29 ohm. So, using the technique of putting output port open circuit and short circuit one by one, you can easily find out the values of ABCD parameters. Now, let us see another example where the transmission parameters are given. So, here you see the transmission parameters in the matrix form. The output port is connected to a variable load for maximum power transfer. Now, what we have to do? We need to find out the value of RL at which maximum power transfer will take place, and we need to find out how much maximum power will be transferred. So, what we will do? We will utilize the same process which we discussed. We will first put output port open circuit and then short circuit to find out the relationships, and when you are required to find out the value of RL for maximum power transfer, the objective will be to find out the Thevenin equivalent of the circuit which is left to the RL. So, this particular segment needs to be represented as Thevenin equivalent. So, we will use ABCD parameters and find out the value of VTH and RTH, so that we can find out the value of maximum power to be transferred. Now, first what we need to do? We have to determine the Thevenin impedance and Thevenin voltage. First, let us find out the value of Thevenin impedance. So, for that what we have to do? To find out the value of Thevenin impedance, we need to short circuit all the independent voltage source. So, here this independent voltage source we will short circuit, and then to find out the value of ZTH, we will apply 1 volt voltage at the output port, so that we can find the value of V2. So, when you get the value of V2 and I2, you can simply find out the value of ZTH. So, this relationship V2 and I2 we will get with the help of ABCD parameters. So, if you put the values of A, B, C and D, you can simply write V1 and I1 as V1 is equal to 4 V2 minus 20 I2, I1 is equal to 0.1 V2 minus 2 I2. Now, if you see at the input port, V1 is equal to minus of 10 I1, because the direction of I1 is opposite. So, we can simply say V1 is minus of 10 I1. So, this we get from the input port. So, if you substitute this relationship into first equation, what we get? We get I1 equal to minus 0.4 V2 plus 2 I2. Now, applying the above value to the second equation. So, if you set the value of I1 as minus 0.4 V2 plus 2 I2 in the second equation and simplify, what you get? You will get 0.5 V2 is equal to 4 I2. Now, you know that what is ZTH? That ZTH is nothing but V2 upon I2. So, with this you will simply get the value of Thevenin impedance, that is equal to 8 ohm. Now, next task is we need to find out the value of VTH. So, for finding out the value of VTH, the value of current I2 will be 0, because this port will be open circuited, and the input port, the value of V1 will be now 50 minus of 10 I1. So, if you see the value of V1, that is 50 minus the current flowing, if current flowing in this direction, this will become 50 minus 10 I1. Now, we apply this to ABCD parameter equations. What we can write? We can write 50 minus 10 I1 equal to 4 of V2, because V1 is equal to 4 of V2 and we set I2 is equal to 0. So, V1 is equal to now 4 V2. So, this will become 4 V2, and next is I1. I1 is again 0.1 V2, because I2 is equal to 0. So, you get another equation, I1 is equal to 0.1 V2. So, this will give V2 is equal to 10 I1. Now, you put the value of V2 in this and simplify, and when you simplify you will get simply the value of V2 as equal to 10. And what is V2? V2 is nothing but the Thevenin voltage. So, we get now the value of Thevenin voltage at 10 volt, and then we will apply maximum power transfer theorem. At the maximum power transfer condition, your variable load RL should be equal to Thevenin impedance. So, the value of RL we can set equal to 8 ohm, and what will be the maximum power transfer? That will be equal to VTH by 2 RL square into RL. So, this is as per the maximum power transfer theorem, and when we apply it, we simply get the value of power P as 3.125 watt. So, with this we can close our today's session, in which we discussed about the transmission parameter and inverse transmission parameters. In next lecture, we will discuss about the interconnection of various two port networks, which we have discussed in the last 4 sessions. Thank you.